In this tutorial, I'll show you how to solve rate problems leading to fractional equations. This is question 2. The question reads, Crew A can assemble 2 cars in 5 days, and Crew B can assemble 3 cars in 7 days. If both crews together assemble 100 cars, with Crew B working 10 days longer than Crew A, how many days must each crew work? We are told some critical information about Crew A and Crew B. We're told that the rate Crew A works at, the rate is 2 cars per every 5 days. And Crew B works 3 cars every 7 days. So this one is slower than Crew A. If both crews together assemble 100 cars, so the total amount of work done is 100 cars, with Crew B working 10 days longer than Crew A. To present that algebraically, we write T is equal to T plus 10, where T represents the amount of time that Crew A works, and therefore the time for Crew A will simply be T. How many days must each crew work? To do this, we'll need to follow this formula here, where work done is equal to the rate of work times the time. In terms of Crew A, the rate of work done is 2 over 5, and the time is T. And for Crew B, we have 3 over 7, and the time for them is T plus 10. And together, they will produce 100 cars. So to model this algebraically, we'll take the work done for Crew A and the work done for Crew B, add them up, and it should equal to 100. So the work done for the first crew plus the work done for the second crew is equal to 100. And now we have to solve this linear equation. You want to start off by trying to eliminate the denominator by finding the lowest common denominator, and the lowest common denominator amongst all of these terms is 35. So let's multiply this whole equation by 35. Multiplying now each term by 35, 35 divided by 5 gives us 7 times 2 is 14t. 35 divided by 7 is 5 times 3 is 15, t plus 10, and 35 times 100 is equal to 3,500. I'll multiply this 15 into the bracket, and this gives me 15t plus 150. 3,500 doesn't change. Bringing this over, 3,500 minus 150 divided by 29. And the way I got 29 is by combining 14 and 15t together. Dividing both sides by 29 to isolate for this t gives you 3,500 minus 150 divided by 29, and that is 115.5. 115.5 days. This number right here represents the time Crew A put in to manufacture these 100 cars. And to find out the time that Crew B put in, you'll take 115 and add 10 to it, which gives you 125.5 for Crew B, while Crew A was 115.5. And so there you have it. That is how to solve rate problems leading to fractional equations. Make sure to catch question 3 for another example.